demonstration that I was going to show for the solution to the midterm problem, the bonus problem, which was to find the a solution for the Towers of Hanoi, where initially the disk could be in any place. So quick reminder, the Tower of Hanoi, we have 3 pegs, which we'll call 0, 1, and 2. We have a number of disks, in this case 5, and we can only move, we can move a smallest disk anytime, anywhere. Any others, we can only move them if they're on top, so I can't move that one, but I can move this one. I can move it over here because it's smaller than what's already there, but I can't move it over here because it's bigger than what's on top. And of course, if a peg is empty, we can always move a small disk onto it, as long as it's the smallest disk from its source peg. So to solve the problem for 5, we want to move them all to peg 2 over here, and so we can do this in a 3-step process. First, I need to move the 4 smallest out of the way, so I'm going to move them to peg 1. Then I'm going to move this disk, the biggest one, to peg 2, and then I need to move the 4 smallest to peg 2. So watch for those 3 steps. It's going to go fast. Here we go. First move 4 to peg 1. There they are, and then the big one moved, and then the 4 get moved on top of it. So to move 5, we need to be able to move 4, and we need to be able to move a disk just on its own. So of course, to move 4, we can do that if we can move 3, and to move 3, we can do that if we can move 2. And finally get down to where you don't need to move any at all, and then you're done. Slight variation on that. If the disk we're trying to move, the biggest one of the, let's say we're trying to move 5, so the biggest of those 5 is already where we want it, then the 3-step process becomes a 1-step process. We can just skip right to the last step, which is to move the 4 others on top of it. So here we go, and the last 4 just go on top of the biggest one, so we didn't have to move the biggest one at all. But if we have to move the biggest one, then fine, then we'll just do that. We'll just move the other 4 out of the way, which means over to the 3rd disk, 3rd peg, which is over here, the one that's not involved in this move. Then we'll move the orange one, then we'll move the other 4 on top. So away we go. That's the first part, and now we're into the 3rd part. So that's it in terms of code, very simple. If n is 0, there's nothing to do. Otherwise, we take the largest disk, which is n minus 1. If it's already where it needs to be, we skip to the 3rd step, which is to move the other n minus 1 on top of it. Otherwise, it's a 3-step process. We move the other n minus 1 out of the way, the smallest n minus 1 out of the way, move that biggest disk n minus 1 moves, and then the n minus 1 smallest move on top of it. You might recognize that this is a tail recursion, so we could apply tail recursion removal, and in that case it just boils down to a nice little while loop. But it's the same thing.